Hello and welcome to Psych319, Chapter 5, Part 2. Um, so we're talking about short-term memory. Sensory memory does not have capacity limits. And what we mean by capacity limits, we mean that there is a limit to the amount of memories that you can store, the amount of information that you can process. So when we look out at the world, we can see all the information that's there. We can't remember everything, but it all passes through sensory memory quite easily because the job is only to preserve the sensory information. Now, short-term memory, on the other hand, has capacity limits. We can't remember everything. If I give you a very, very large array of numbers, ask you to memorize 150 numbers, it's going to be very hard for you to remember those numbers. In fact, the data shows that we can really remember about 7 things plus or minus 2 items on average. That's the magic number of short-term memory. And by no strange coincidence, phone numbers are about that long. Makes them easier to remember. To give you an example of the short-term memory demo, I want you to try and remember as many of the following objects as you can. Okay, sorry, they weren't objects. All right, so how did you do? Did you remember? Here's the answer. Did you remember all 12? Did you write them down? Did I give you enough time? Okay, pretty hard task. I want you to try the same thing again. Okay, after you write them down, and if you go back and check, you probably got a lot more here because you probably recognize that the numbers were, or the letters were in groups, ABC, CBS, NBC, Fox. So these are all, of course, television networks, whereas this answer is just a letter string, just random letters. It's easier to group these into little chunks of information. That means that instead of memorizing 12 letters, now you just have to memorize 4 things, which fits into the magic number, which is 7 plus or minus 2. So it's easy to remember 4 groups of things. The second group is probably easier because we could chunk the information into manageable groups. Chunking is the idea of taking a large amount of information and grouping it so that it makes it easier to remember, and the brain does this all the time. So then why do we forget? Why don't we just chunk everything? Well, there's certain things you can forget and certain things you can't. It's very difficult to forget things like your name. That stuff is hardwired. You hear it too frequently. It's very, very rare when you forget your name, like on paperwork or something like that. It happens, but it's just a momentary lapse of attention or whatnot. Think about what you tend to forget. You probably tend to forget the most boring and mundane things in the world, the things that are not important to you. We're good at remembering things that are biologically relevant. So it makes sense. Why would we forget stuff? It makes sense to forget information that you don't need because it's not biologically relevant to you. You're not going to use it. When you ride the train in the morning, you don't remember all the faces on the train because you know you're not going to see half of those people again, most of those people again. But if you're introduced to somebody at a party or at school, there's a very good chance you're going to remember that face. You might forget their name, but you'll remember that face. So what helps us remember things when we think we've forgotten them? I'm going to give you a demo before we approach the idea of cueing. I'm going to give you a demo of the serial position effect. So, oh, sorry, we're going to do the slide first, then the demo. Okay, so people tend to remember things at the beginning and the end of very long lists. So if I introduce you to 100 people at a party, you're more likely to remember the very first people that you met and the very last people you met. You might forget the names of the people in the middle. So this is a serial position effect, going from the first person to the last person you meet. And this is your ability to recall based on the position in which you met them. And there's 2 effects. One is called the primacy effect. And the primacy effect occurs because you have more time to rehearse these names. So if the first person you meet is John Smith, you have a lot of time to remember John Smith's name before you're actually tested, which is at the end of this event. The other effect is the recency effect. Recency occurs because there's less information coming in, so you're more likely to remember the more recent names. These names in the middle, they're forgotten because they don't have a lot of time to rehearse them, but more importantly, with every new name you learn, your causing and creating some kind of interference that interferes with the names that occurred that you learned beforehand. So these don't have any new names to interfere with them, so you get a recency effect. So that means there's kind of this primacy and recency effect points to two different ways of forgetting: decay and interference. So decay occurs when memory traces degrade because they're not rehearsed. If I show you a number on a screen and I don't ask you to rehearse that number, you're eventually going to forget it. But interference is different. Interference is when you are trying to memorize something, but you're having difficulty because you're being bombarded with new information. New information competes with rehearsed memory traces, and then you're not allowed to encode a quality memory, and therefore you forget it. So here's the experiment. Try and remember as many of the following as you can. I'm going to go pretty fast. Okay, so write them down. You'll have to pause the tape. I'm going to assume that you can pause this. So I'm going to move on. You can also go back and check your answers, see how many you got correctly. And after you've done that, let's do another round. Try and remember as many of the following as you can. Okay. So you might have noticed, check your work, see how well you did. You might have noticed that you probably did better on the second task. Probably part of this is because you're getting better at the task. But there's another reason. You noticed probably the categories changed. In the first list, you had 14 car brands. So every time you memorize a new one, it competes with a bit of information that you've already memorized. And so you're getting some kind of interference. We'll talk about the difference between proactive and retroactive interference in a second. In the second example, the list switches from flowers to sports. And what happens is with the changing categories, you get less interference because it's like you're starting a whole new category of things to remember, and so sports tends not to interfere as much with flowers. So we call this a release from proactive interference. We're sort of, by changing categories, we're eliminating the effect of interference. So forgetting is a function of decay and interference, and you can see that demonstrated in that last example. I'd like to introduce another concept. So short-term memory has a very close cousin called working memory, and working memory is essentially the same thing as short-term memory, but through the years the idea of short-term memory has expanded and evolved, so we tend to think of things as working memory now. So short-term memory appears, as you know, to have many functions, including encoding, rehearsal, and recall. And a classic experiment gave subjects a dual task where they had to remember a bunch of numbers and then also make grammatical judgments about sentences. So they're doing two things at once. It's very, very, very hard. But what was interesting is despite the fact that they had this extra task, while they started out they were quite terrible, with practice they could still remember 7 plus or minus 2 digits. So with lots of practice, they could still do both tasks at once. So what does that mean? Because if you have capacity limits, then how are you able to do 2 tasks at once if you're already meeting your capacity limit with the numbers task? So here's the idea of the working memory model from Baddeley and Hitch. Here you have the main memory systems model that we talked about before: sensory memory, short-term memory, and long-term memory. And this middle column here essentially is the same as short-term memory, but now it's been divided into several groups. You have a portion that's dedicated to visual information, and then you have a portion that's dedicated to auditory information, so that a person can complete an auditory task and a visual task, and they sort of have their own memory storage spaces. And so you're allowed to kind of use the capacity limit of each one without them causing too much problems, without you running out of capacity limits. And so we call the visual one the visual spatial scratch pad, and the auditory one we call it the phonological loop. So when you think about rehearsing a phone number, chances are you're not thinking the phone number visually, you're probably rehearsing it auditorially in your head. That's the phonological loop. It's really important for learning language. And all of this, the total amount of energy or amount of memory you have available, the total amount of capacity you have available, depends upon your overall memory store. And it's governed by a central executive. So some larger part of your brain, some more important decision-making part of your brain decides which of these tasks to allocate more memory to, and does so accordingly. So other facts. It's the same thing. So attention does act as a central executive. So if you're paying attention to, in the Baddeley and Hitch experiment, if you're paying more attention to the numbers task, you'll do better on the numbers task. If you're paying more attention to the auditory task, you'll do better at the auditory task. But if you've gotten enough sleep and you have a large well of attentional resources to allocate, like we talked about in previous chapters, you'll be better at distributing your capacity limit across both modalities. So short-term memory can be divided between a phonological loop and the visual spatial sketchpad, and it has that important job, again, of transforming sensory information into a code that can be rehearsed. It can be auditory, it can be visual, but then it eventually is transformed into long-term memory. So in brief, I'm going to start off with this last bit. Where are memories stored once they leave short-term memory? Well, it's, again, not a particular location, but it's a network. It's a group of cells that encode a particular idea or concept or experience. Sensory memory is thought to live in the region between the sensory receptors and the primary sensory cortices. So sensory memory, the very short-term memory, is mostly associated with the receptors and the eyes and ears. That's sort of close to the peripheral neural system. Long-term memory, on the other hand, is stored in the association cortices as a distributed network. So there's not one particular cell that represents your grandmother or the picture of a coffee cup, but rather a group of cells is activated. And when that small group of cells is activated, then you'll experience the memory of your grandmother. Short-term memory, on the other hand, is a very weird animal. We'll get into the actual physiology later. But there are two loops. There are more than two loops, but there are two general loops that are responsible for rehearsal and encoding retrieval. Rehearsing is a loop that runs between the hippocampus and the frontal cortex. So the frontal cortex is involved in planning, and what the hippocampus does is allow you to take that information and sort of predict, using the planning centers of your brain, of how it's going to relate to other information that you know. Encoding and retrieval happens with the hippocampus and the association cortices. So if long-term memories are stored around the association cortices, if you want to recall something, the hippocampus has a loop with the association cortex, and in that loop, it activates that memory and brings it into short-term memory so that you can bring it into conscious awareness and act upon it. All right, looks like we managed to fit it all in just two fun-filled slideshows. So I hope you enjoyed that one, and we'll move on with the other sections of memory in the succeeding chapters.